We have the last speaker for the day for this session, Mr. K.S. Varaprasad. Please come. He is a scientist G and is a project director DRDO. He did his bachelor's from in electronics and communication from JNU University, Anantapur in 1985. And his master's from IIT Kharagpur in 1988. He headed the telemetry division at the Integrated Test Range Chandipur, Range System Division and Instrumentation and Project Director at DRDL Hyderabad. He has earned 8 national level awards and for path-breaking research and outstanding technological development. He is going to today speak to you on Helena long-range air-to-ground missile for attack helicopters. Over to you, please.
Thanks. Good afternoon, everybody. The first two speakers, first Dr. Prasad Sampath, he has talked about the design of the attack helicopter, there is a light combat helicopter. Then next, Major General Baroli, as a user, he wanted a weapon for this. So, correctly I am placed in the end to provide a weapon for this helicopter, and that is Helena. Basically, as a part of the IGMDP, Integrated Guided Missile Development Program, to play the role of anti-tank guided missile, NAG has been planned and it has been developed mainly for the mechanized infantry and with a range of 4 kilometers. Lock on before launch. After launching, no more guidance. It will go autonomously to the target. At that time, it was planned to be developed for helicopter also, Chetak. But later, as the light combat helicopter has come into picture, once you fly, obviously you are also vulnerable. So the army has asked correctly for a longer standoff range weapon. So wherein there is a requirement to enhance the range of the NAG to 7+ kilometers. So this is the requirement. But then, as the LCH was getting developed, if we take up a development of a new missile, it will be obviously calling for more time and development cycle. Keeping that in mind, so the DRDO has decided to take up this in 2 phases. First is utilize the existing and proven technologies of NAG, including the aerodynamic design, add some LRUs, radio link or fiber optic link, and then extend the range and make it compatible to the helicopter operations. This will solve the problem immediately. Parallelly take up the development of a high resolution seeker, which will offer a standoff range of 7+ kilometers. So first, we have started with the first approach, making the existing NAG missile compatible for 7.5 kilometers attack range. Here, we wanted to use all the technologies as proven in the NAG. Obviously, for range, we have to increase the propulsion, either sustainer or booster, and we have to have a guidance aid. Otherwise, it is not possible because you cannot just see with this current seeker more than 3 kilometers. So that is why we have decided after a lot of studies that an efficient and secure and anti-jump proof 2-way RF data link, both for command transmission upwards and the video and some health parameter reception in the downlink. And this shows the scenario. Now, what is that guidance scheme that what is the guidance scheme that you are able to listen? Okay. What is the guidance scheme that we have contemplated to use in this? First, the pilot or the weapon system officer, using the helicopter what Dr. Prasad Sampath has presented in the morning, it has got a powerful electro-optical target acquisition system. It has the facility of auto tracking also. So he will locate the target with the electro-optical tracking system. Then he has confirmed, yes, this is the target that we have to engage. Then the helicopter is steered to that azimuth to within the possible accuracy, that is within plus minus 5 degrees. This is what has been, it is possible. After that, the target acquisition system is put in the auto track mode. With the conventional systems available, accuracies of the order of 0.05 degrees are possible when you are tracking. Then at this point, the Helena missile, which is attached to the armament boom, that configuration also slightly later, which is harmonized with reference to the access of the TAS, target acquisition system, to an accuracy, best possible accuracy. So at this point of time, once the missile seeker is slaved to the target acquisition system direction, for sure the missile seeker will be looking in the intended direction where there is a target. Here there may be two situations wherein the target may be visible if the day is very clear. Even at 7 kilometers, we may not see exactly the target but a replica of that. Our second option is you may not see the target. In either case, because we have slaved the seeker to the target acquisition site direction, once we put the gate at the center of the area what we are seeing, obviously you are in the right direction, may not be on the correct target. So at this point of time, the missile is launched. Once the missile is launched, the guidance scheme employed within the missile will ensure that the missile will maintain within this selected azimuth and elevation by plus minus 1 degree. And the field of view of the seeker currently is 3 degree. We are contemplating to reduce it to 2 degree later. So, for sure, the seeker is seeing in the direction of interest. As the range comes to the seeker range of visibility, through the downlink, which is a very efficient link, the pilot will start seeing the image of the target scene, wherein he may see the correct target. Then he places the gate. On. He moves the gate. That comes later. I think slides are slightly misplaced. Okay. Here, based on the range, once he is in auto track, LRF is fired, so you get the range, get to know the range. Then the onboard computer decides the trajectory based on the range, whether it is lofted trajectory or direct trajectory. All this information is there. Even the WSO has got the facility to overwrite. Then WSO places the track gate on the seeker page, and WSO gives the target track command, which starts course tracking of the gated area. WSO launches the missile. Based on the range acquired, the shaped trajectory is selected. Okay, now it's correct. Now seeker continues course tracking aided by track gate movement and sizing by the WSO if he finds a drift in the selected area. Once he starts seeing the target, he will be able to move the gate to the intended target, and then this is mid-course guidance. Then WSO, when he can clearly identify a potential target, he places the gate, and then he has two options. If he is confident of guiding the missile even further, he will be able to utilize the gate controls with the RF data link and he can guide the missile, or he can go to autonomous mode and press a lock. Once a lock is pressed, then the auto track errors developed by the seeker will dictate the guidance errors, and the guidance loop will take care, and the missile will ultimately be guided towards the target. This is the concept which we intended to use, and here the two things is the operation of the RF data link, its anti-jam features, and the resolution of the video which is coming, which is displayed to the pilot. These will play a major important role, and these are the technologies which are specifically developed for this missile Helena compared to Nag. All other systems we intended to use the same. Now the next challenge is we have to be compatible to the helicopter, because basically Nag has been developed for the mechanized infantry. Within the tank all the fire control systems are there, and this weapon has to work in conjunction with the other weapons available on board the helicopter. So the fire control system which is specific to the Helena should provide compatibility in terms of the interfaces and the logic of operations as decided by the WSO, parallel to other weapons what they are done. So basically this is already available in the helicopter. So from here onwards we have to provide interfaces when this ATGM weapon system is selected. So this FCS will take over, and the FCS will be having links to the each launcher interface unit which is sitting on the launcher itself. Each launcher interface unit can control 2 missiles. So there are 4 LIUs, 4 launchers, and this is the maximum configuration. So each attack helicopter in its maximum configuration can carry 8 Helena missiles on 4 launchers. So if we remove 1 launcher, 2 missiles will go. And each launcher is autonomous by itself by way of its launch controls, RF data transmission reception. The transmission reception is autonomous on each side of the helicopter. On the left side there is one system, on the right side there is one system. And LIU has its own cooling system. The cooling system is capable of operation for 2 hours for 2 missiles. And this is the sortie time given to us. So once you take up a sortie, for 2 hours, even if you continuously cool, it will be able to take care of the requirement. Now this is how it looks, LIU 1, 2, 3, 4. And between 2 weapon stations, we have got a transmit-receiving antenna. Similarly, here also there will be one transmit-receive antenna. From FCS to here, there are all 1553 links. So, because of this industry standard, we are able to design the FCS, and now the FCS is ready. Now, this is how it looks when we integrate onto the boom. These are the 2 weapon stations, 4 missiles, 4 missiles. Here is the transmit-receive antenna, and in the fuselage, all that other FCS and other systems are placed. Now, the next challenge is the launcher. Basically, helicopter, the vibration environment is very severe compared to any platform. So, when we make a launcher, we have to keep in mind we should not be responding to these frequencies. One is the main rotor frequency, other the crossover frequencies, and the harmonics of that. So the launcher should be designed accordingly. So it should be low weight, but it should be able to take care of the load of the 2 missiles and the corresponding LIU and the cooling system. So the budget given at each weapon station, we should be around 150 to 200 kgs. So it is a very big challenge. Basically the analysis and modeling and design, this is very difficult. So now this launcher with all these inputs has been developed and it is captive flight tested. So there is no worry on this part. Now this is the cooling system what I was telling. Now coming to the Helena missile, this is generally it is a Nag missile which is there in the, it's available, and these are all the sections. This is the control actuation, propulsion, wings. Then this is the RF data link and sensor, warhead, and this front is the seeker. So these are all the subsystems. And the capabilities, now earlier it was 4 kilometers. Now with this enhancement, now it has become 7 kilometers. The missile will be housed in a tube. The tube is put on the launcher. There will be 2 tubes on each launcher. And after every sortie, the tube will be removed. Launcher will remain, and only the missile, this launch tube and missile only has to be changed. So we have taken care in the launcher design that it will take exactly 2 minutes to change both the missiles after it lands. So these are all the inputs given by the user, so we try to follow them. Top attack and direct attack capability, low smoke propellant, and the tandem warhead, which is a very big success in Nag. We are able to defeat ERS of thickness up to 800 mm. So this is a tandem warhead with a precursor and main charge. And this is the just a overview of the RF data link. And now the possible applications. When we fit this missile on the attack helicopter, need not be a tank, anti-tank. It can be called as air-to-ground missile. Wherever there is a heat, it will be able to detect, and we will be able to guide the missile. And in the growth potential, now once we prove this, once we have the lock-on before launch with 7 kilometers seeker and use the RF data link, we can even think of defeating non-LOS targets. And the present sensor package, we have already plans to upgrade them to a miniaturized INS packages. So the capabilities gets enhanced without increasing the cost or any other weight of the missile. So we can think of even extending the range beyond 15-20 kilometers. And another application is, we have now UAVs developed in DRDO also, that is the Rustam and other things. We have also plans to have a feasibility study on equipping those UAVs with this Helena missile. So these are the possible applications. I think with this I'll close. Thank you.
Thank you. That was a very enlightening talk. If there are any questions, please. Yeah.
Yes, yes. Yes. Yes.
The question is regarding the missile guidance system. As I've understood, it can be guided through the radio frequency, and you have IR seeker as well.
Yes.
So the philosophy of like attack hapter, they say that they'll be operating in numbers in the tank maneuvering area or whatever target area. So we assume attack hapters to be in the vicinity at around 200-300 meters apart.
Yes.
Now, if you're guiding a missile with a radio frequency, have you thought of any coding on a particular missile or a radio frequency, something like that? So
Yes.
that
Yes. We have considered.
So we are working on the 2 codes or different frequencies.
No. There may be many codes. It's simple spectrum technology we are following. We're employing both multi-carrier CDMA and multi-code CDMA. All these aspects have been taken care. If you want any minor details, I can give you. Right.
If there are any more questions, please. Thank you very much. We had a very nice session on helicopters. We had 3 speakers, and each one of them had given us a lot of insight into their subjects. Thank you very much for this session.